Welcome. In this video, I'm going to be working Algebra 2 Quiz 5.2, which is all about polynomial arithmetic. So we're going to be adding, subtracting, multiplying, and dividing polynomials. And so the first one, we're going to find the sum, and this is just going to be combining like terms. So in x to the thirds, I'm only seeing 8 of them. Okay, x to the 2, I'm seeing 4 on the right side. First power of x would be negative x, right here, plus a negative 2x, and then a negative 1 plus 3. And now I'm going to combine like terms. Okay, like terms, things with the same variable and the same exponent. So negative x minus 2x would be negative 3x, and negative 1 plus 3 is positive 2. Okay, so that's going to be the sum. The difference, first thing I'm going to do is distribute the negative to all of these things, and then I will combine like terms after that. So I'll have x to the 4 plus 2x to the 3 minus 5x to the 2 plus 7x minus 2x to the 4 plus x to the 3 plus 5x to the 2 minus 1. Because I've got to distribute this minus to everything, because it's really like a minus 1 multiplying by that thing in parentheses. And then I'll think about my fourth power terms. Okay, I'll have 1 minus 2 is negative 1 x to the fourth. X to the third power terms, I'd have 2 plus 1 is positive 3x to the 3's. X squared, negative 5 plus 5 is no x squared, 0x squared, so I'm not going to write anything. Okay, 7x, that's the only x I see. And then the last one will be, okay, that negative 1 is the only constant I see, so I'll have minus 1. Okay, and that'll be the difference. Alright, now I'll find the product. So with a big multiplication like this, I'm going to recommend that you use the box method. So I'm just going to kind of use the one that's already written on the page and say x squared positive 6x and positive 5. Then I'll just multiply all these things together. Okay, multiply all these things out, and then I'm going to combine like terms after that. So I'm really looking for all of the x to the 4s. I'm seeing just 1 x to the 4. Okay, on x to the 3s, I'm seeing 6 minus 2, so that would be plus 4x to the 3. X to the 2s, I'm seeing it right there. Negative 14 plus 5, that feels like negative 9x to the 2. Yeah. And then with the x's, I'm seeing negative 10 minus 12 would be minus 22x, and then there, minus 10. And that's the product. Alright, find the quotient. Now, if we're dividing two polynomials and we're seeing that we're dividing by just x plus a number, x minus a number, that's a really good chance for us to use synthetic division. So that's what I'm going to do right here. I'm going to copy the coefficients of the thing I'm dividing. 1x to the 3, 2x to the 2, negative 13x, and positive 8. Divide that using synthetic division, and the number that I'm going to put outside is whatever would make the denominator equal to 0. So that's x equals 3. And always the same with this. I drop down the first number, I multiply, and then I add. Multiply, add, multiply, add. Takes a second to check, yeah, it looks right, and then I'm going to copy out the quotient from these numbers that I'm kind of left with down here. Okay, so if I divide x to the 3 by x, my quotient should start with 1x to the 2. So I could start, from the left and say 1x to the 2, 5x, 2, and then the remainder is 14. But I think the safest way to go is to start with the remainder. So I've got a positive 14, and we know the remainder goes over the divisor, so it's that x minus 3. And then after that, it'll be constant some number of x's, so positive 5x's, and then 1x squared. Okay, and that's going to be the quotient. This next one, on the other hand, I'm going to have to use long division, okay? Because I'm not just dividing by x plus a number, x minus a number. And I'm not saying that in general this one must be done by long division or it can't be done by synthetic division, but I'm not going to be doing it by synthetic division in this video. Okay, and I don't recommend that you do it either if you're in my Algebra 2 class. So I'm just going to set up for long division. 2x to the 3, I like to leave good amount of room, but I need to add some room above 2. So 2x to the 3, positive 17x to the 2, positive 2x, and negative 5. Okay, and I'm dividing by 2x plus 1. I think to myself, what do I multiply this 2x by to get 2x cubed? And that would be 2 times 1 is 2, just 2 powers of x. So I'll multiply that x squared onto the 2x plus 1, and I'll get 2x to the 3 plus x squared. That's what I'm going to be subtracting here. Whoops. And 2x to the 3 minus 2x to the 3 is nothing. 17x to the 2 minus an x to the 2 would be 16x to the 2. I'll drop this down. And that would be great. So I think, what do I multiply 2x by to get 16x squared? Well, I would need to multiply by a positive 8 and 1 power of x. If I multiplied 8x by 2x plus 1, I would get 16x squared plus 8x. So that's what I'm going to be subtracting away. I get 16 minus 16 is no x squared. 2 minus 8 would be negative 6x. I'll drop that down and I'll have negative 5. I need some more room, it looks like. There's none to have, so what am I going to multiply 2x by to get negative 6? That would be minus 3. And so if I multiply that minus 3 by 2x plus 1, I'll get negative 6x and a negative 3. Okay, subtract that all away, and there's just enough room for a remainder. Negative 5 minus negative 3 would be negative 2. Okay, so I'll have minus 2 over 2x plus 1. Okay, and I guess I'll, in yellow highlighter, my answer. There's really nowhere else to put it. Alright, now I think we've got just a couple of geometry problems, and that'll be it for this version. Okay, find the area of the rectangle in terms of x. Okay, so we know that we find the area of a rectangle by multiplying its base by its height, so I'm just going to do x squared plus 3x minus 5 multiplied by 3x and minus 2. I'm just going to use the box. And then I'm just going to combine like terms. I'm going to double check because I went pretty fast. And yeah, that looks good to me. Okay. Perimeter of the triangle, that's where we're going to add the side lengths together. The thing is, we just need this to be multiplied out before we can start adding things together. So this is going to be x squared plus, now I should be expecting 4 plus 2 x's. Yeah, 4x plus 2x is 6x, and then a 2 times 4 at the end, because we've factored, we've gone from x squared plus 6x plus 8 to x plus 2, x plus 4 so many times we should probably start to expect what's going to happen when you think about it in reverse. And then I'm going to add these things all together. So I got x squared, 6x, and positive 8 plus x to the 3 minus 2x plus 5, and then plus an x plus 3. Right, and then I will combine like terms. X to the 3 is the highest power I'm seeing. In terms of x squared, I'm only seeing that 1. X's, I've got 6x, negative 2x plus x, so that would be 5 x's in total. And then the numbers, I've got 8 plus 5 is 13, plus 3 would be a total of 16. And the last one, this is find the area of the shaded region. Okay, the plan is we're going to find the area of the outside rectangle, and we're going to subtract the area of the inside rectangle. So the area of the outside rectangle is going to be 2x minus 1 multiplied by x plus 7. Okay. Which I think, binomial, if you want to use the box, go ahead, and if that's what you think is the best. If you want to just kind of like make sure you distribute the 2x and the -1 to both terms, that would work too. So I'm just going to distribute 2x times x plus 7 would be 2x squared plus 14x, and then -1 times x plus 7 would be -x minus 7. Okay, so 2x squared positive 13x and -7. Okay, the area of the blue rectangle is going to be x times x plus 1, which is going to be x squared plus 1x. And then the area we're looking for is going to be equal to two things subtracted from each other. So it'll be the red rectangle's area minus the blue rectangle's area. Okay, so I will say, okay, I'm subtracting an x squared and subtracting an x, so that's minus x squared minus x. For the x squareds, I've got 2 minus 1 is 1x squared. For the x's, I've got 13 minus 1 is positive 12. And then -7 minus 1 would be minus 8. Okay, and that would be the area of the shaded region in terms of x. Alright, now let's do form B. So we're going to find the sum, and we're just going to be combining like terms. I only see the 1x cubed, so 5x to the 3. Okay, I only see the 1x squared right there, so it'll be 3x to the 2. In terms of x's, I'm seeing -3 plus -4 would be -7x, and for constants, I see -6 plus 4 is -2. Alright, when finding the difference, I'm going to distribute the negative to all of these things. Positive 2x to the 3, positive 7x, and -3. And then these aren't going to change because they're not getting subtracted. And then I'll group the like terms, x to the 4's, that would be 1 minus 2 is -1, x to the 4. X to the 3's, I've got 2 plus 2 is 4. X squareds, I've got just -5. X's, I've got -7 plus 7 is nothing, and then that -3. And that's going to be the difference. Alright, now we're going to find the product, and anytime trinomial by trinomial, I recommend to use the box method. So x squared, positive 5x, and positive 6. So I'll multiply each of these things across. And then I'll combine like terms. So I'm seeing x to the 4 plus 2x to the 3. 6 minus 18 would be -12. X to the 2, -12 and -33. So -12x to the 2 minus 33x, and then a minus 18. Now we're going to find a quotient, and since we're looking at this denominator that is just not just x plus a number or x minus a number, I'm going to recommend we use long division. So I'm going to set up for long division. 2x to the 3, positive 11x to the 2, -3x, and -6. I divide that by 2x plus 1. So first I think, what do I multiply 2x by to get 2x cubed? Well, that would just be x squared. And then I multiply the x squared back by that 2x plus 1, and I would get 2x to the 3. Maybe I should put that up a little higher. 2x to the 3 plus 1x to the 2. And I'll subtract these away, and I'll have 2 minus 2, x cubed, so that's no x cubes. 11 minus 1 would be 10x squared. I'll drop down the negative 3x. I think what if I multiply 2x by to get 10x squared? That would be a positive 5 and an x. So now I'm thinking, okay, I actually do multiply that in, and I get 10x squared plus 5x. That's what I'm subtracting away. I'll have negative 3 minus 5 is negative 8x minus 6. And then I would need to multiply that 2 here by a negative 4 to get negative 8x. So when I multiply that from down here, I'll have negative 4 times 2x is negative 8x, and negative 4 times 1 is negative 4. That's what I'm subtracting. I'll get myself a remainder here. It looks like it's going to be negative 6 minus negative 4 would be negative 2. Okay. And so maybe I'll go over here and I'll write out my quotient. It's going to be x squared plus 5x minus 4 plus the remainder is negative 2 over 2x plus 1. And you could write it as plus and then put the minus sign in the numerator, but you need to have the minus sign somewhere. And that's number 4. That was kind of a lot. Okay, this one will seem much less because I'm going to be using the synthetic division because I'm just divided by x minus 3. So I copy in the coefficients, 1x to the 3, 4x to the 2, negative 15x, and negative 8. And I'm going to divide that by x minus 3, so I put out here whatever would make the denominator equal to 0. And drop this down, multiply, add, so be positive 6, multiply, add. And then I can just kind of read my quotient off there. And like I said, when I did the other form, you can start from the left or start from the right. I recommend starting from the right because on the right, far right, you're always just going to have the remainder term. So that's going to be a positive 10 over the divisor. Okay, and then the next thing will be x to the 0 power, and then x to the first power, and x to the second power as I move right to left. So positive 6, positive 7x to the first, and positive 1x to the 2. And that'll be my quotient. And this next one's going to ask for an area of a rectangle, so we'll just be able to do that. We'll multiply 2x minus 3 by x squared, positive 3x, and negative 5. And so I'll distribute the 2x across all three terms. Wait, 6x to the 2, because the 2x times 3x would be 2 times 3 times x, minus 10x, and then I'll distribute the negative 3, so it'll be negative 3x to the 2, negative 9x, and positive 15. And then I will combine like terms, and I'm seeing 2x to the 3's, and x to the 2, I'm seeing 6 minus 3 would be positive 3. Negative 10 minus 9 is negative 19x, and positive 15. All right, when finding the perimeter, we're going to add all of the side lengths together. And first we're going to need to multiply x plus 2 by x plus 5. And so I'll get x squared plus 5x plus 2x plus 10. Just write that as x squared, 7x, and 10. Okay, so this perimeter we're looking for is what I just computed, plus the other two side lengths. Right, and then we're going to combine like terms. For x's, I see 7 minus 3 would be 4, plus 1 is 5. And 10 plus 4 is 14, plus 2 would be 16. Alright, for the area of the shaded region, we're going to find the area of the outside rectangle. It would be 2x minus 1 multiplied by x plus 5. And then we're going to subtract the area of the interior rectangle. So that'll be 2x squared plus 10x. And then I'll distribute over the -1, so it'll be -1x minus 5. Area of the interior rectangle will be x times x plus 7. That's going to be x squared plus 7x. And no, I think I can look at it as subtraction just like that, right? It's pretty lined up. If I got 2x squared and I subtract 1x squared, I'll have 1x squared. 9 minus 7 would be positive 2x. And -5, well, I'm not subtracting any numbers, so it'll just be -5. And that'll be the area of the shaded region in terms of x.